Instruction Skill 7 is about solving problems with fractions, add and subtract. So we will have common denominators to deal with in this lesson. Let me get my book up here where I can see it. Okay. Want to start right here. In June, 3 friends wanted to see how far each could run in 20 minutes. They ran on a track and recorded their distances. After 6 months of training, the friends ran again. The results are shown in the table. So let's look over here at this table called the 20-minute run, distances in miles. Luis ran 2.5 miles in June, 2 7/8 miles in December. And then we have Calvin and Jake and their numbers as well. What fraction of a mile farther did Calvin run in December than he ran in June? So here is a huge clue. And here is another one. Specifically in this one, it's the That is a word that means subtraction. The word than also means subtraction. So they want me to look at Calvin's numbers and subtract those two. So I have 3 1/4 minus 2 7/8. Now, you can use my trick of turning those into decimals, and I'll show you how to do that in just a minute because that is what I would do. But let me show you the right way, and then we'll worry about that one. The first thing I need to do is get a common denominator. So if I think through the multiples of 4 and 8, I know that the 8 will work. It's already working on the bottom. But here I would need to say 4 times 2 is 8 and 1 times 2 is 2. So I no longer have to worry about this mess. Here are the two fractions now that I need to subtract. So after I get my common denominator, I do have some work to do here. Because I cannot take 7/8 away from 2/8. Just like in regular subtraction, if that bottom number is bigger, you better borrow. So I'm going to borrow from this 3 and make it a 2. And then I will rename the 1 as 8/8. So I haven't lost anything. I still have 3. I've just renamed this one so that I can combine it with that one. So what I have now is 2 and 10/8 because I am adding that 8 and that 2 to get that 10. And the denominator doesn't change. It comes over there just like it is in the first part. And then 2 7/8, the bottom one will never change. Your work will always be on the top. And you end up with 3/8. So 3/8 of a mile is the answer. And that is what we have here. Now they want me to record that on the grid. So when I come over here, I would write the 3/8 up in the top and then color the 3, the fraction bar. You have to put the fraction bar in there. Otherwise, you will have 38, and that is not the right answer. So to grid a fraction, you use the fraction bar. Okay, if you wanted to do this with decimals, we have 3 1/4, 2 7/8, and this is exactly what I would do. And I already forgot what I said. 3 1/4, 2 7/8. I would convert these to decimals. I'm not rounding. I'm doing actual numbers. 3.25 and then 2.875. I would have to put in a 0. And the borrowing is a little bit easier here because you borrow from this one and give to this one, and you would have 5. It's not much easier, but I would rather do it. 0.375 and 0, and then I would have to turn that back into 3/8. But you can do it that way if you prefer that, and if you know your decimal equivalences. That's a good one. All right, so here's their solution. To find the difference between numbers, subtract. When the numbers are far apart, the difference can be estimated. The numbers in the table and in the answer choices are too close to use estimation. So first we need to find Calvin's distances. And we did that. We found the June and the December. To subtract, you have to find a common denominator. And we did that. We used the 8. The June distance already had a denominator of 8, so we only had to rewrite the December distance. Then they went an alternate way. This is interesting too. So let me walk you through this one. This is a good way to do it. They took the 3 1/4. Oh, I like this. I didn't think of this, but this is a good way. And remember, we made this, we built it up to eighths. So we had 2/8 minus 2 7/8. So first we got the common denominator. Then you make the mixed number mad. So you will take this process for both of them. So 8 times 3 is 24, plus 2 is 26 over 8. And then you make this one mad. 8 times 2 is 16, plus 7. 16 plus 7 is what, 23 over 8. And then you can subtract. You keep the 8 on the bottom. 26 minus 23 is 3. So that will also give you 3/8 of a mile. That is another way you can do this problem. So I've already shown you 3 ways. We did the green way up there, we did the decimal way, and then we did this way. And here's yet another way that you could do it. Alternate step 3, show the distances on a number line marked off in eighths. And we want eighths because that is our common denominator. So then we would count the 1/8 distances. So what they've done, they've drawn a number line, a kind of ruler, and they marked the December distance, and they marked the June distance using the common denominator, and then they counted those intervals. So they had, there's 1, 2, 3, and that gave them the 3/8. So you have 4 methods from which to choose. All of them are fine. There is none better than the others. It just depends on how you see it and what makes sense to your brain. But the answer we're looking for is 3/8. On page 27, I would make sure that I've done the computation review for 132 through 135. That will help you with these fraction concepts. And speaking of concept, here is a concept question. Rita walked 1/8 mile to a neighbor's house. She then walked 2 3/4 miles with friends. Later in the day, Rita walked 2 1/3 miles home. Which is the best estimate of the total number of miles Rita walked? Well, total tells me that I'm either adding or multiplying. And since these are all different numbers, it would have to be adding. So 1/8 of a mile is really not even enough to count. It's just a few steps. So I'm going to say, with respect to estimating, it's nothing. It's 0 miles. 2 3/4, that's 2.75. That is very close to 3 miles. And then 2 1/3, that third is less than half, so I'm just going to leave this one at 2 miles. It's not enough to round it up to 3 because it's less than half of a mile. And we know that we have to total these. So I would say approximately 5 miles. So I like answer 4. Sometimes an estimate's good enough. You don't need to know exactly. You just need a ballpark figure. And this works really well when your numbers are very different, when there's a lot of difference between them. This is a good question. A procedure question. Before he began working out in the gym, Sammy weighed 147.5 pounds. After working out for 1 week, his weight dropped to 146 3/4 pounds. What fraction of a pound did Sammy lose? Well, you know what I would do, but let me just show you what I would do. I would say 147.5. He's losing weight, so that's subtraction. 146.75. Put a 0 in there. And then you can subtract without using fractions. I'm going to do it the other way because I'm supposed to. But I want you to know that this way will work as well. So he lost 3/4 of a pound. But let's do it the way we're supposed to. We have 147.5 minus 146 3/4. And we need a common denominator. I know that 4 will work. So let's just do it that way. And let me take out these. All right, this one's already in terms of fourths. You just bring the 3 over. But the 2, we have 2 times 2 is 4. So on top, we would have 1 times 2 is 2. And then once you get those into those common denominators, this part is gone. But I'm subtracting 3/4 from 2/4, and that won't work. So I'm going to make this become a 146, and I'll rewrite this as 4/4. And then I'm going to combine these two to get 146 and 6/4 minus 146 and 3/4. And when we subtract those, we will get 3/4 of a pound. And then to grid this, we would write in 3/4 and color 3/4. So however you get the 3/4 pound on some of the GED questions, you do have to grid them that way. So be very careful with that. Number 3, the average height of a 16-year-old girl is 65 inches. The average height of a 16-year-old boy is 68 3/8 inches. How much taller is an average 16-year-old boy than an average 16-year-old girl? Both of those are telling me to subtract. So the boy is a little bit taller. Put that number first. Subtract the 65 for the girl's height. And here you can just bring down that 3/8. Then 8 minus 5 is 3, and 6 minus 6 is 0. So the answer is 3 3/8 inches, or number 2. There was nothing weird there to borrow or do anything strange. Application, and you may use your calculator. I always love to see these. Instructions for sewing a crazy jacket say to buy at least 3 yards of fabric remnants. And a crazy jacket is one of those where you take all these scraps of fabric and you make them into a piece that you can sew a jacket from, or any piece of clothing. So far, Janice has picked out remnants measuring 5/8 yard, 1/2 yard, and 3/4 yard. How much more? That's one of the most important phrases in all of math. It means subtract. How much more fabric does Janice need? This is a multi-step equation. You can use your calculator, so I am not going to work out the fractions longhand. I'm going to do it the way I do this and use decimals. So 5/8 plus 1/2 plus 3/4. That's how much Janice has. Janice needs 3 yards. So we're going to take what she needs. We're going to subtract what she has. And that will tell us how much more she needs. So you can put this in your calculator right here and get your answer. I unfortunately do not have the Casio calculator. So here's how I would do it anyway. I just like decimals. The 5/8 is 0.625. 1/2 is 0.5. And 3/4 is 0.75. This my cell phone will do, if I can find my cell phone. And then we're going to subtract that amount from the 3. Now you can use the scientific calculator. You don't have to do the decimal route. This is just my habit of a lifetime. So this is 1875. And then I will subtract that from 3. And that leaves me with 1.125, which I know to be 1 1/8. So that would be option 5. Again, you just put this into your calculator at this step and it will give you the answer. But you do have to use those parentheses. Okay. It says to use the table on page 26 for problem 5. So let me go back to page 26 and take a quick picture of this table. I do not want to have to keep going back and forth. And that is not what I meant to hit. That wanted to start an AI chat, which we don't want to do. All right, so let's come back over here and paste this chart. All right, which of the following statements are true given the data in the table? A, Jake was the fastest runner both in June and December. Well, if he ran for 20 minutes, in June, he did not get the furthest. He was actually covered the least ground. So that is not a true statement. He was the slowest one in June, because he was in the 1s when the others were in the 2s. So that is not our answer. Comparing their June distances to their December distances, both Calvin and Louise improved by the same amount. This is a calculator question, so make good use of it. Calvin went from 3.14, 3 1/4 or 3.25 to 2 7/8. We're going to subtract that. So 2.875. We can use the calculator. So you can put a fraction in. You can also do it with your decimals if you know those. It's worth learning the decimals to be able to do this, in my opinion. And then we want to compare Louise, who did 2.875 minus 2.5. Again, I'm going to make use of my calculator if they allow me to. And sure enough, this came out to be true. They both improved by 3/8. So yes, this is a true statement. I'm going to mark that. So A is false, B is true, but we do need to look at C because we could have more than one true answer. The difference in the distances run by the fastest and slowest runners was greater in June than in December. So be careful here. Look at June, and when I say that, I mean this column. Who was fastest and who was slowest in June? Calvin ran further in 20 minutes. Jake ran the least. So those are the two that I'm going to look at for June. We have this one and this one for June. And while I'm here, I'm going to go ahead and get December. Who was the fastest in December? It was still Calvin. And who covered the least amount of ground? It was still Jake. But he did improve significantly. Now, we need to find the differences between those two. And I tell you what, let me make this green so we can not get that confused with the one that I've already done. So let's do this one and this one. I'm going to do the June numbers first. So for June, we have 2 7/8. I'm using, actually on this one I don't have to, because the fraction is not going to need a common denominator. 2 7/8 minus 1 7/8. So 7/8 minus 7/8 is 0. And then 2 minus 1 is 1. And there's no fraction. So we would just say the difference is 1 mile. And then in December, we do the same thing. We have 3 1/4. I am going to use decimals here. Minus 2 3/8. You can use the calculator and fractions. It is fine. In fact, that's what you're supposed to do. I just don't have the fraction calculator with me. So this was a little more than 1/4 of a mile, and I forgot the statement. The difference in distances run by the two runners was greater in June. That is true, because in June it was a whole mile difference. In December it was not. So B and C are true, and that would mean that my answer is number 4. Goodness, what a problem. That's a good one, but it is very time consuming. I won't be sad to leave the fractions behind.